Part B here of the 2008 question was the most asked from the differential equation and particular solution homework. So essentially, what I want to keep in mind is anytime that we have a differential equation like that, and we're being asked to find a particular solution, and that's typically the language, especially if they give us some kind of initial condition like that right there. They're really asking us to go back from the derivative. Can we find what the y function was? That's what they're really asking for. And that's why we have this acronym. We have this procedure here, SIC. So I'm going to go ahead and use that. And if I kind of have that in the back of my mind, it makes these much easier. So I know dy dx equals y minus 1 over x squared. So let's see, what do I want to do first? Well, I want to separate. So let's go ahead and separate these variables. I'm going to collect all my x's on my right-hand side. So I'm going to multiply both sides by dx to cancel out the x on my left-hand side. And then similarly, I'm going to divide both sides by y minus 1. Just use some algebra there. And that's going to cancel out my y minus 1 on this side there. So then what I'm going to get is 1 over y minus 1 equals, dy equals 1 over x squared. That doesn't look like a very good x squared, does it? Dx. Now, I chose to write these in that fashion because I know my next step up here is to integrate both sides. And so I kind of want it look in that familiar form where I would go ahead and integrate. And so by having the 1 over y minus 1 and the 1 over x squared and the dy and the dx kind of separate, it looks like that familiar integral form. So I'm going to go ahead and now at this point, I'm just going to use that second step there. I'm going to integrate both sides because that's what we do when we have a derivative and we're trying to find the antiderivative. And so on my right-hand side, I realize that 1 over x squared, that's kind of ugly. I'm going to think about that as x to the negative 2 because that's going to allow me to use my anti-power rule. This is something we should be able to do. So I'm going to get negative 1 over x. I want you to think about how I got that. And at this point, I'm going to make a choice. I'm going to go ahead and put my plus c in right now on the right-hand side. Because that's the side with my x's. That's the side where it feels kind of most comfortable. My y side, I'm not going to include my constant. And if you don't recall why that is, like why I can choose to put it on one side and not the other, I'd encourage you to go back and watch the introduction video. So now what about that left-hand side? Well, that left-hand side kind of looks ugly. I mean, I really wish that, that denominator was just y, because then it would be ln. This is where we can u sub, right? And we can go through that u sub process. I'm going to, just so we all understand what it looks like. I'm going to say u equals y minus 1. And so then what we really have here is the antiderivative of 1 over u. Oh, but I need a substitute for dy. So come back over to our side work. Take the derivative with respect to y on both sides. I'm going to get du dy equals 1, or du equals dy. Because now I can go ahead and substitute, right? I can take out my dy there and I can put in a du. So I get this. And then when I anti-differentiate that left-hand side, I know I'm going to get ln of u. Now, I'm forward thinking, so I realized, because I already tried to work this out one time, and I realized where people are getting their issue. And it's because we can't have just the derivative or the antiderivative of 1 over u as being ln of u It's actually, and this is super important, super important, it's the ln of absolute value of u. And if you think about it, we have to have that absolute value there because what if u is a negative value? If u was a negative value, we'd have issues, right? Because we can't take the natural log of a negative number, any log of a negative number. And so that's why those absolute value signs have to be there. And I'm wondering if this is what caused a lot of our problems. So anyway, at this point in time, if you look at it, I've separated, I've integrated. I remember to put my c right there over on the right-hand side. So I've used that process. So I kind of have my solution, right? But I need c. And that's why they always give us that point, right? That they call it the initial condition. So what does that tell me? Well, it tells me that if x was 2, then y would be 0. Ooh, and that's really the ln of the absolute value of y minus 1, right? Because I don't really know what u is. And so that's really ln of 0 minus 1 or negative 1. We can see why that absolute value becomes so important. So we're going to get the absolute, or the natural log of 1 equals negative 1/2 plus c. I'm going to erase this work over here so we have a little bit more space. So now we need to know natural log of 1 is, what's the exponent on e that would make 1? Well, that's 0. And so 0 equals negative 1/2 plus c. And so I know c is 1/2. And that was important. So now if I go back to kind of where I was, like, right in here-ish, right? We now know the ln of the absolute value of y minus 1 equals negative 1 over x plus 1/2. Now, if you can go no further, I want you to understand that if this were an AP test, at this point, you have probably gotten 4 out of the 5 points or 5 out of the 6 points. Matter of fact, go and look at the rubric right now and you'll see that I'm right. The only information, the only point that I'm missing is they ask for the solution. When they ask for the particular solution, I'm going to come over here and get rid of that highlight. When they asked for the particular solution, they said they want it in this y equals form. The only thing I haven't done is the algebra. That's 1 point for doing the algebra. If you're going to give up a point, give that point up, right? Like, don't fail to show all of this awesomeness because of, the ending algebra, okay? But I'm going to go ahead and take care of this for us. So I really want to get rid of this ln here. So I know I can use e, or I can kind of change this into, log. This is really log base e, right? And so I can kind of change this from a log form. So it's really, ln is really log base e. So I can go ahead and change this from log form into, exponential form. So I can really say, all right, well, this means that e, and to the, keep in mind this is all the exponent, right? So e to that, e to the negative 1 over x plus 1/2 equals the absolute value of y minus 1. Now, absolute value, again, this is where the algebra is coming in. Keep in mind, absolute value, it could be, really, it's just going to put it's going to multiply it by a negative, or it's going to leave it alone, right, depending on what it is. And if I know that y equals 0 has to be able to be plugged in here, so I'm going to have an exponential on my left-hand side there, right? This is exponential. That's always going to give me a positive value. And I know that I'm going to be able to plug in 0 here for y. So I know and this is where our work from last year comes in handy. I know what that means for me is really I'm going to have to, if I want to take these absolute values off, I'm going to have to multiply this by a -1. And the reason there is because it's going to take that what would have been negative and it's going to make it positive. And I know I need it to be positive because this left-hand side is going to be positive. So I need my right-hand side to be positive when I plug in y equals 0. And so then, you know, in the end there, what we're going to get, and go ahead and create some space over here for us to do some work, is we're going to get e to the -1 over x plus 1/2 equals -y plus 1. And I can just solve at that point in time. E to the -1 over x plus 1/2. I can subtract 1 from both sides, and that's going to equal -y. Right? And then I can just go ahead and multiply both sides by a negative. And there's my final answer. So what I would stress at this point, don't forget this acronym. If you're solving a differential equation, if you're trying to find the particular solution, separate, integrate, don't forget C. Second thing I would stress, the antiderivative of 1 over x dx is ln of absolute value of x. Absolute value of x, not just x. And then relax on the algebra. Okay, if you get bogged down, leave it alone. Get the points where you can. Okay. Hope this helps. Take care and see you soon.